Dear students, today we are discussing differentiation and integration of transforms. Okay, let us consider the Laplace transformation f of s equal to integral 0 to infinity e raised to minus st f of t dt. Then f dash of s equal to, the differentiation is with respect to s. So we can see that f dash of c is equal to minus integral 0 to infinity e raised to minus st into derivative of e raised to minus st, that is minus t f of t dt, by the application of the interchange of integration and differentiation. Okay, you will get this result. So, but this is actually Laplace transformation of t f of t, okay, with the minus sign. So that way can be represented as L of t minus t is equal to minus f dash of s. That means f dash of s is equal to minus L of t f t. Equivalently, we can say that L of t f t is equal to minus f dash of s. So normally we will have L inverse of f dash of c is equal to minus t f of t. Okay, so that is the inverse of minus t f of t. So we can derive these three formulas of Laplace transformation of L of f, that is 1 by s square plus beta square all square, that is a Laplace transformation. So what is the inverse? F of t is equal to 1 by beta cube into sin beta t minus beta t cos beta t. So we can derive that. Okay, so you know that L of t sin beta t, what is L of t sin beta t? We can easily say that we know that what is the L of sin beta t, that is beta by s square plus beta square. So what will be L of t sin beta t? So f of s is equal to what is that, beta by f of s is equal to L of sin beta t, so that will be beta by s square plus beta square. Okay, so what is L of t f of t, that is minus f dash of t, that is L inverse of f dash of t is equal to minus t beta t. So what is f dash of s? What is f dash of s? We have identified that f of s is equal to beta by s square plus beta square. So what is f dash of s? Yeah, 2 times what is that? Minus beta by s square plus beta square all square, minus beta by s square plus beta square all square into derivative of s square plus beta square, that is 2s. So minus 2 beta s by s square plus beta square all square, that is the derivative of f dash of s. So what is L of t sin beta t? Minus f dash of s. So minus will get cancelled and we will get just 2 beta s by s square plus beta square all square. Okay, similarly what is the case of cos? I will show that formula here. What is L of cos beta t? That is s by s square plus beta square. L of cos bt equal to s by s square plus beta square. Okay, so what is L dash of cos beta t? What is L dash of cos beta t? S square plus beta square into derivative of s minus s into derivative of s square plus beta square, that is 2s, okay, divided by s square plus beta square whole square, okay, right? So that is given here. So that is s square plus beta square minus s square plus beta square whole square. So normally we can apply these two equations, equation number 4 and 5, and you will get, yeah, then what is L of t cos beta t? Minus f dash s. So we will put a one minus sign here and we will get the result like this, okay. So we obtain f dash of s and we will put one minus sign, then you will get this result, okay. So what is L of beta t cos beta t plus or minus 1 by sin beta t? Yeah, we can substitute the L of the result Laplace transformation of L of t cos beta t here, plus or minus L of 1 by beta into sin beta t, that is 1 by s square plus beta square. You will get this formula, okay. So I think you got the idea of differentiation of Laplace transformation. You try to work out this problem, okay. Next is integration of transformation. So what is that? L of f of result is nothing but L of f of t by t is equal to integral s to infinity f s tilde d s tilde, and L inverse integral s to infinity f s tilde d s tilde. So this is the formula, so that is equal to f of t by t. So you can derive this formula very easily. First of all, let us consider integral s to infinity f s tilde ds dash equal to integral s to infinity, what is f of s, integral 0 to infinity e raised to minus s tilde t f of t dt ds tilde, okay. We can interchange the integration order of the integration that is considered here. So that is equal to integral 0 to infinity f of t into integral s to infinity e raised to minus s tilde t ds ds tilde then dt, okay. There. ഇവിടെ ആരെങ്കിലും ഉണ്ടോ പുറത്ത്? പെൺകുട്ടിയാണെങ്കിലോ? തൊട്ടപ്പുറം ടോയ്ലറ്റ് ഉണ്ട് അവിടെ, എൻട്രൻസിൽ, താഴെ തന്നെ കാണാം, അവിടെ ഇട്ടാൽ മതി. ഇറങ്ങി വരുന്നിടത്തുണ്ട്, അതായത് ചെരിഞ്ഞ റോഡല്ലേ, ചെരിഞ്ഞിറങ്ങി വരുന്നില്ല, അതിൻ്റെ സൈഡിലുണ്ട്, അവിടെ കിട്ടും. Here this is yeah, you can take integration e raised to minus with respect to this, yeah, we can integrate this function and that will result in this function e raised to minus s tilde t by minus st, that we can put here, and then result will be integral 0 to infinity e raised to minus st f of t by t, okay. We can substitute the range from s to infinity. When we substitute infinity, it will become 0. When we substitute s, it will become e raised to minus st by minus t, and also we have one minus sign, so that will be get cancelled and it will be plus sign. So f of t by t dt. So this can be represented like this, L of f t by t, okay. So the result is integral of the transformation, integral of a Laplace transformation is nothing but Laplace transformation of f of t by t. So that is a beautiful result, okay. So let us consider an example. Consider the transform ln 1 plus omega square by s square, that can be simplified like this, ln s square plus omega square by s square. So what is f dash of s? Differentiate. Then d by ds of log s square plus omega square minus L of s square. After differentiation you will get 1 by s square plus omega square into derivative of s square plus omega square, that is 2s, minus 1 by s square into derivative of s square, that is minus 2s by s square, okay. We can find the inverse of this Laplace transformation. What is the inverse of this transformation? Just 2 into cos omega t. What is the inverse of this function? Just 2. Okay, that is minus t f of t. So we can see that L inverse of f dash of s is equal to minus t f of t. Okay. So what is the hence the inverse of f of t of f of s is what will be what will be f of s? F of s will be what is that? This one is 2 into cos omega t minus 1. That means 2 into cos omega t minus 2 equal to minus t. This is by theorem. This is by theorem. Minus t f of t. So from this 2 term we can see that f of t is nothing but 2 into 1 minus cos omega t by t. Okay. This is another case. This is alternative method. You can try for that also. Okay. Whatever be the method you can use. Okay. So we have discussed 2 results, that is differentiation of the transform and integration of the transform. So these are the application of differentiation and integration of transform to the certain Laplace transformations. Okay. You can have several examples in the exercise part. You can do all these examples or work out and submit to me, and I can check the result. Okay. That will help you to study in detail. Another case we will discuss this. These are general formulas. We have already discussed all these results, and I think we have almost completed the section of Laplace transformation. And these are the formulas you can derive, or I think some of the problems are we have discussed. These problems 21 to 24, that is the application of differentiation, integration of transformation. Okay. This is also by the application of similar formulas. You can do all these problems. You can expect problems from this table in the examination. Okay. So you have to do all these problems. Several problems are there. Okay, I think it is over. Laplace transformation section is over. What is this? This is summary of the chapter. Okay. So anyway, let me stop the discussion of Laplace transformation today, and we will move to the Fourier series, Fourier transformation analysis. So you know, you can see that some functions that can be represented as a series expression. Okay, some function can be expressed as a using some in the real analysis you can express some function or any function in Taylor series form. Okay, or Maclaurin series form. I think you have studied in the degree classes Taylor series and Maclaurin series. So what are the application of Taylor series and Maclaurin series? So they are actually giving an approximation as any function or a function satisfying the conditions of that theorem can be represented as a series representation. Okay, so similar approach is similar approach you can see in the Fourier series analysis. I will take, and then I think it will be in 4. Fourier. Where is it? Fourier. Yeah, I think this is some Fourier. Yeah, Fourier analysis. It's very important in mathematics, and moreover, it is very important in our probability theory, because we are considering this type of analysis in deriving the results in central limit theorem, carriage function, etc. So you have to get the idea of this Fourier series expression, Fourier series analysis, at least in basic level. So that is the aim of introducing this paper in the first semester, because we need this result to understand the probability theory, Gauss function theory, etc. in detail. Okay. So this chapter is devoted to Fourier analysis. So I told you, by using Taylor's theorem or Maclaurin theorem, you can represent any function in terms of as an approximation of approximation using f dash, f double dash, etc. Okay. In this case, in Fourier analysis, we are considering only periodic functions. Okay. In Taylor series expression, we are considering any function satisfying certain conditions, differentially up to order some k or some p, and etc. So in this Fourier series analysis, we are considering only periodic functions. So we are approximating periodic function using some technique. Okay. So this is a periodic function. It is repeating over a period. The length of the period is p. Okay. Length of the period is p. So this is the repetition of the first end is the repetition of the last end. Okay. So you can represent like this: f of x plus p is equal to f of x. Okay. So the period may be, sometimes the period may be pi by 2 or 2 pi, etc. For example, sin x cos x, that is the function sin x cos x, etc. It is repeating periodically, the value is repeating periodically with a period 2 pi. Okay. So the trigonometric function, normally the trigonometric functions and combinations of the trigonometric functions are periodic. Okay. So we can expect the function in Fourier analysis having some trigonometric equations or trigonometric functions like cos x, sin x, sin hx, cos hx, etc. Moreover, it may have the functions like x square, x cube, etc., e raised to x, etc. Okay. So we are representing f of x plus np is equal to f of x for all x, and p is the period, and n is equal to 1, 2, 3, etc. Okay. So what examples are given here: sin x, cos x, cos 2x, sin 2x, cos nx, sin nx, etc. So these are the examples of periodic functions. So we are considering only periodic functions for the Fourier analysis. So what is the idea of Fourier series? Yeah, the series of the form a1, some constant a0 plus a1 cos x plus b1 sin x plus a2. This is usually called a trigonometric series. Okay, or Fourier series. Okay, and period may be pi or 2 pi, etc. Whatever be the function, the period may be different for different function. Okay. So this series, f of x equal to a0 plus summation I from 1 to n a n cos nx plus b n sin nx is called Fourier series. Okay. That means left side is a function. Okay. Left side is a function which is a periodic function. What is right side? Right side is a series representation of cos x and sin x. Okay. So any periodic function can be represented like this. Okay. That is the advantage of using Fourier series analysis. Any periodic function can be represented as in this form, equation number 5. Okay. So these constants a0, a1, bn are called Fourier coefficients that can be obtained as a0 is equal to 1 by 2 pi into integral minus pi to pi f of x dx, an is equal to 1 by pi into integral minus pi to pi f of x cos nx dx, bn equal to 1 by pi into integral minus pi to pi f of x sin nx dx, n equal to 1 to 3, etc. Okay. Here we can see an example. Consider this example: f of x equal to minus k from minus pi less than x less than 0 and k if 0 less than x less than k. We can find the n constants a0, an, bn using the above formula. What is an? N is equal to 1 by pi into minus integral minus pi to pi f of x cos nx here you know that f of x is minus k for this section. So integral minus pi to 0 minus k cos nx plus integral 0 to pi, the next section, that is 0 to pi. There f of x is k cos nx dx, that equal to 1 by pi into minus k sin nx by n, from minus pi to 0, k sin nx by n 0 to pi equal to 0. So this the result of an is 0. So what is bn? 1 by pi into integral this is a method of finding an and bn. You have to understand this. Bn is equal to 1 by pi into integral minus pi to pi f of x sin nx dx plus that equal to 1 by pi into integral minus pi to 0 minus k sin nx dx plus integral 0 to pi k sin nx dx. So when we substitute 0, it will become 1. When you substitute minus pi, that will be minus n pi. When we substitute pi, it will become cos n pi and cos 0 1, and you will get this one. Okay, bn is equal to, it is given here 2 times, equations are coming 2 times, so we can 2 into k can be taken outside, k by k n pi into 1 minus cos n pi. Okay, but you know that cos pi is equal to minus 1, cos 2 pi is equal to 1, sin 3 cos 3 pi is equal to minus 1, etc. Okay, so you can substitute that formula, that value here, and then you will get cos. So what is 1 minus cos n? That will be 2 for odd n, and it will be 0 for even n. These are all getting from this after substituting this result in this equation. Okay. Okay. So okay, the sen b1 is equal to, you can see that b1 is equal to, just put n equal to 1. So for this is 2 to here. So 2 into 2. So 4 pi by 4k by pi. Okay. b2 equal to 0, b3 equal to 0, b4 equal to 0. That's it. You can verify that. This is the shape of that function. It is periodic function. So we have obtained the series expression like this. Moreover, you have to verify that a0 is 0 or not. Surely, since f of x is, that is when we substitute the f of x value in a0 value, a0, then you can see that it will be 0. Because this is minus k, this is plus k. When we integrate this minus k plus k in this region, you can see that a0 will be 0. So this is the series expression. Okay, this is a Fourier series of substituting an 0 and bn values. Okay, we can substitute the bn values, and then you can see that what is the series expression. Yeah, this is the series expression. a0 will be 0 and ans are 0, then bn are given. So you will have only sine term. Okay, so that is why we can see sine term only. Okay, here you can see there is only sine term. Okay, so this is a special case. You can substitute the value x pi by 2, x equal to pi by 2 here, and you can see that this is 4k by pi into sine pi by 2 is 1. So 1 plus 1 by 3 into sine 3 pi by 2 is minus 1. So minus 1 by 3 and so on. Okay, that is the result obtained here. So this is the result. And you can see that f of pi by 2, that is this is k. This is k, and from this equation you can see that this series, you can take this pi left side, k to left side, then the remaining term only pi by 4. Okay, you will get the result. This. So you can see that this sum of this series is pi by 4. So that is the application of the Fourier series analysis. You will get the sum value of some unknown series. You know the sum of 1 plus 1 by 2 plus 1 by 2 square plus etc. You know the sum of 1 by 2 plus 1 plus 1 by 2 plus 1 by what is that? 1 divided by 1 minus x. I think 1 divided by 1 minus 1 plus 1 by 2 plus 1 by 2 square plus etc. That is 1 by 1 minus 1 by 2. So that type of equations, you know, that can be derived using Maclaurin series or Taylor series. So this type of complicated series can be simplified using Fourier series analysis. So this is another, okay. You can discuss this one also. So this is orthogonality of trigonometric system. Okay, you know that trigonometric system is orthogonal on the interval minus pi to pi, and that is the integral of the product of any two functions in 3 over that integral is 0. So that for any integers n and m, equation number 3, we have to refer equation number 3. The result is integral minus pi to pi cos nx sin mx dx equals 0. Second is minus pi to pi sin nx sin mx dx equals 0. Third is minus pi to pi sin nx cos mx dx equals 0. Okay. You know that integral minus pi to pi cos nx cos mx dx. What is cos nx cos mx? I told you have to refer the trigonometric functions, trigonometric results. I think I have shown you in the Google in the last class some of the trigonometric formulas. So you can apply that trigonometric formula here, then you will get cos m plus n x dx plus half into cos n minus m x dx. Okay, that is the application of trigonometric formula. And you know that this cos value will be, what is that? It will be sine, and the sine pi will be sin 0 0, sin pi 0, and minus pi 0. So this will be 0. Okay, and the cos will be replaced as sine, and if it is n equal to m, what happens? Cos 0, so that will be 1. So that is 1 by 2 integral minus pi to pi 1, that is 2 pi by 2, so that is pi. Okay, if n equal to m, this will be pi, but if n not equal to m, that will be 0. The result is only for n not equal to m. And in this case also you can see this formula. In this case also, if n not equal to m, this will be 0. Okay, similarly in the case of sine function, we can put like this, sine, so it will become cos. After integration it will become cos. So cos pi is 1, and cos minus pi is cos pi, that is again 1, so that will become 0. In this case also that will become 0. Okay, so that's why you will get this A, B, C result. Okay, so you can integrate the Fourier series expression, that is integral minus pi to pi f of x dx equal to integral minus pi to pi, that expression of Fourier series dx. So you can take the integration inside, so that step is given here. Okay, so what will be the result? This one, integral integral will be a naught into integral minus pi to pi dx plus summation n from 1 to n a n into integral minus pi to pi cos nx dx plus b n into integral minus pi to pi sin nx dx. Okay, first term is 2 pi with a naught, so 2 pi a naught. Okay, the second term and third term will be 0. Okay, after integration it will be 0, because this is symmetric, this is a periodic function, cos and sin are periodic function. So after integration it will subtract each other, so value will be same. Okay, now integral minus pi to pi f of x cos mx dx. So we can substitute integral minus to pi, the expression of Fourier series substituted here, cos mx dx. Okay, then first term Then on the right we obtain an integral of a0 cos mx, a0 into cos mx, first term. So a0 can be taken outside, and the integral of cos mx is 0. Okay, the second term is an into cos nx mx, which is an into, I have told you already in the previous part, if n equal to m, that is pi. Okay, this will be pi. This will be pi. If n equal to m, this will be pi. So you will get it is am into pi. Okay, and if n not equal to m, it will be 0. That is discussed earlier. And then for the second term, this will be 0 for all n and m. Okay, using the above discussion. 9c, question by 9, question 9c. Hence, you will get, what is that? You will get an only. So, an will be integral of this one divided by pi. Okay, because the right side is only am into pi. So, am will be 1 by pi into left side. Okay, similarly, integral minus pi to pi f of x sin mx dx equal to, you can apply this integration, and integrating first time will be 0, and second term is also 0, and third term bn into sin mx, which is bm into pi. Okay, bm into pi if n equal to m, bm into pi if n equal to m. Similar case as in the previous case. Okay, so bm will be 1 by pi into this left side. Bm will be 1 by pi into this left side. Okay, so you will get the expression for an, bn, and a0, an, and bn. Okay, that is not given here. Anyway, we can see that an equal to 1 by 2 pi into integral minus pi to pi. What is that? Where is it? F of x dx. An equal to 1 by pi into integral minus pi to pi f of x cos mx dx, nx dx. Bn equal to integral minus pi to pi f of x sin nx dx. So that will be the result. Anyway, you may write up to this, and we will discuss the remaining section after studying this section in detail. Okay, so you have to study in detail, and you have to spend a lot of time with this section, and then only you can understand the concept. We have only 20 days more for completing our syllabus, so we will anyway we will complete that in time. We will have an examination, offline examination. That examination you have to come in the campus and then write the examination. I will inform the date and